Hi, welcome. This is part 2 of the study guide. And in class we did mostly the odd numbers, so don't focus too much on if we didn't get to a question. The questions I'm going to require for homework are question 2, 4, 10, 12, and 13. Okay. So on the back of what was your homework from the previous night, it says part 2. So let's do it. Question 2 looks like this. Okay. But also on it says make sure to draw a picture on another piece of paper and show all your work. So we're going to make just a quick sketch of the triangle. It says we have a ladder 15 feet long. And okay, so we have a ladder 15 feet long. At one point, it's scooted up the wall 11, and another point, it's scooted up the wall 13. So we're given these two numbers are the same, 15 and 13, but it looks like, and if you kind of use logic here, it seems as if this one's going to be smaller than that one. Because if I think about a wall here, I'll try to fit a little demonstration. This, if my pen is the ladder, so let's just use my pen as a ladder. If I scoot it up the wall, see how my pen gets closer to the wall. So my pen doesn't get shorter, but if I scoot it up, it goes up on the wall a little higher and the bottom of the ladder gets closer. And that's what they're asking. They're saying, in order to reduce the distance of the ladder from the building, how much further in the ladder is figure 1 from figure 2? So this is a regular old Pythagorean theorem question. So I'm going to make this x. I get a squared plus b squared c squared. A squared is x. B is 11. The hypotenuse is 15. So just running through the math, I'm going to subtract on both sides. And there we go. So now I'm actually predicting that this might be a little smaller. So I can finish that one. That's for this picture. Let's do it for this one. Same formula. Now that number's 13. Interesting. So I do get a smaller number here. And again, these numbers are square roots. And now the question says, leave your answer to the nearest foot. So that actually means you're allowed to round. Wow. Okay, so you can turn this into a decimal and round to the nearest whole number or nearest foot. Okay. So when I take the square root of this number, I get 10.198. I take the square root of this number, I get 7.483. Okay, so it says, what's the difference? So this one is about 10 foot off the wall. The bottom of the ladder is 10 foot off the wall. And this one is about 7 foot off the wall. And so it looks like the difference, how much further, the difference would be just subtracting them. Now we could round at the very end. We could do 10.198 minus 7.483. And I get 2.715. Yeah, and that still would round to 3. Round to the nearest foot. Cool. Now let's do question number 4. Question number 4 says we have a square. So the area of the square is 900. And we know the area of a square has the formula side squared. So whatever this is times this would equal the area. And I wouldn't necessarily have to put base times width because I don't have two different measurements. So we can substitute the number 900 in where we see the letter A. and rewrite the equation. So 900 equals side squared. And the square is keeping the s from being by himself. So we end up getting the side is equal to the square root of 900, which is 30. So that's nice. This one's the first time we got a nice question. So we have a square that's 30 by 30, and we can double check that. If we take 30 squared, we definitely get 900. So I can find the perimeter of this square, because the perimeter of a square is just add up all four sides, and all the sides are equal. Okay, and they gave me the question in inches. They also want to know what's the length of the diagonal. And so what they're really doing is cutting a square in half. Cool. Okay, so this is a combo question. It kind of brings in what we knew before. So it's saying if I had a square that was 30 by 30, what would be this length? And that would be the diagonal, or also known as the hypotenuse. So it looks like leg, leg, hypotenuse. So we noticed a pattern in class that whatever the leg is, the other leg is, because it was a square, and the hypotenuse is whatever that number is times the square root of 2. So following the pattern, 30, this leg's 30, and the hypotenuse, or the diagonal, is 30 times the square root of 2, and this is what they're asking for, the diagonal. Awesome. Now, those questions were awkward the other day in class, but they're starting to we'll get the hang of those. Now I said we're going to jump to question 10. I'm actually going to do 12 on this video, and then I'll put 10 and 13 on the same video. So let's do question 12. Question 12 says, what's the length of 30, 60, 90? Okay, so 30, 60, 90. If the length of the hypotenuse is 15, and what's the perimeter? Okay. So we had a question really similar to that. I think it's like, this is like question 9. So we want to know the perimeter, and it looks like this was an equilateral triangle somebody cut in half. So we got to put short leg, since all three are different, short leg, long leg, hypotenuse. So the short leg, if it's a number, a regular old number, the short leg we can call x. The long leg is x times the square root of 3, and the hypotenuse is 2 times the short leg. Now, the annoying thing here is that that's not an even number. If it was 16, then that would be 8, and that's 8 times the square root of 3. But it's not. So we notice that we know the hypotenuse is 15, and so here's our equation. All right, so we know if we divide both sides by 15, this might help make things make sense. So, I get it. This has to be 15 halves, and this would be 15 halves times the square root of 3. So it's still the same pattern, but the short leg is 15 halves. The long leg is 15 halves times the square root of 3, and the hypotenuse is 15. And this happens each time the hypotenuse is odd. So now we can find the perimeter of a triangle if we add up all three sides, and the three sides all look like kind of interesting different numbers. One side's 15, one side's 15 halves, and the third side is 15 halves times the square root of 3. If we add these together, we notice that this one we have to leave the same, but these two we may be able to combine. So in class, we multiply 15 by 2 so that we can show the number 15 as 30 halves. So 30 halves is the number 15, but if I rewrite it this way, I can combine it with this term. So as I rewrite the perimeter, I'm almost done. Now I can combine these. So 30 plus 15 is 45 over 2. And I have my final answer. Awesome. Check out the next video for question 10 and 13. Thanks for joining us.